Hello everyone, welcome to this next question on complex analysis. This question is from GATE 2014 and it is of 1 mark. The question is very easy. They are asking what is the maximum modulus of this complex number e to the power z square, where the limits are given to be these. So let us solve this question. In order to calculate the maximum modulus, we need to determine the modulus of this function first, right? So we first need to determine what is this. So if we assume e z square to be some complex number a plus iota b, so firstly, in order to calculate the magnitude of this function, right? So we should calculate a and b. That means we are looking for something of this sort. So let us first simplify this. Let us substitute x is equal to x plus iota, z is equal to x plus iota y. So from here we would have e to the power x plus iota y whole square, right? So we can open up this square quantity. So we would have x square minus y square plus 2 iota times 2xy. So this is the quantity. So now this is the real part and this is the imaginary part with iota. So we can write this as e to the power x square minus y square multiplied by e to the power iota times 2xy. So now we have this formula e to the power iota theta. We can write this term as cos of theta plus iota sine of theta. So here we would use this result. So it would be e to the power x square minus y square as such, and in place of this we can write this to be cos 2xy plus iota times sine 2xy. So this is the thing, right? So here we can write the part, we can separate these two parts. So we would have e to the power x square minus y square multiplied by cos of 2xy, and then plus iota times, we can write this to be e to the power x square minus y square multiplied by sine 2xy. So now can you see this part over here? This is the real part, and this part over here, this is the imaginary part. So in order to take the modulus, what we need to do, we need to square the real part. So that would be e raised to power 2 into x square minus y square, and this the square of this cos term, so cos square 2xy, plus we need to take the square of this imaginary term. So it would be again be e to the power 2x square minus y square, and then the square of the sine term, sine square 2xy. So this is the modulus. So here we can take e to the power 2x square minus y square common. So we would be left with cos square 2xy plus sine square 2xy. Now because the angles over here are same, that is they are equal to 2xy, so we have this thing to be 1. So we are only left with e to the power 2x square minus y square. This is the modulus square, right? If we are calculating the modulus, so this whole thing square root, because the formula over here was square root of the real part square plus imaginary part square. So we would take the square root of this whole quantity. So in effect we are left with e to the power x square minus y square only. So this is the modulus of the given term, and in order to calculate the maximum modulus when the given ranges are, we are given that the real part of z lies between 0 to 1 and the imaginary part of z also lies between 0 to 1. So we are given these bounds. So now we may have an approximate or a rough idea if we substitute these endpoints onto the modulus. So let us first assume that real part of x is the real part of z. Z was x plus iota y, so that means real part of z in effect is x only, and the imaginary part of z is in effect y only. So this is the condition that we have. So now we can we can use the end conditions. So firstly assume x is equal to 0 and y is equal to 0. So our modulus become e to the power 0 square minus 0 square. So that simply is e to the power 0, which is 1. So let us now calculate for when x is 0 and y is 1. In that case it becomes e to the power 0 square minus 1 square. So e to the power minus 1 by e. So obviously this 1 by e is less than 1. So this is the maximum if we are only considering these two cases. If x is 1, y is 0, in that case we would have e to the power 1 square minus 0 square. So that would be e to the power 1, which is e. And lastly we'll substitute x is equal to 1 and y is equal to 1. So in this case we would have e to the power 0, which is equal to 1. So out of these four, we can clearly see that the maximum value over here is this e when x is equal to 1 and y is equal to 0. So we can state that the maximum modulus of the given function is e. So option B is the correct option in this case. Well, that is it for this video. Thank you for watching.